Hi everyone. Today we're going to be learning about tectonic plates. If you should need me, my email address is on the screen. It's rcrawford@jcpsmail.org. Please do not simply send me a message in Google Classroom. I often do not get those until weeks later. So let's jump right in. To begin with, I just want us to think a little bit more about Earth's physical layers. Now, we said the physical layers are the layers of Earth that are based on behavior, on the properties of the substances, not on the composition. And so we said that we have five physical layers. Those physical layers, starting with the outermost layer, is a lithosphere. And the lithosphere is a solid. We also have the asthenosphere, which is a semi-solid, maybe also called semi-liquid. In the middle, we have the mesosphere. And please notice that the lithosphere, asthenosphere, and mesosphere, we know that those are all made of rock because we've already looked at those chemical layers. As we move more toward the center, we have the outer core, which is a liquid, and then we have the inner core, which is a solid. I really want to take a moment and I want to look a little bit more today at both the lithosphere and the asthenosphere. So our lithosphere is a solid, but one thing that I need you to understand, it is made of brittle rock. Okay, so when we look at the lithosphere, we can see that that's this light gray layer right here, um, and it is a solid. So notice how this includes all of the crust and a little bit of the upper part of the mantle that is not melted, right? So that's still acting as solid. So when I use the word brittle, anything that's brittle is that just means that it's hard and it's very rigid, but it's also going to break or fracture easily. So that is one of those properties of the lithosphere that turns out to be important for us as we're looking at these two layers in particular. Underneath the lithosphere, we have the asthenosphere. Remember, we've said that's a semi-solid. We've said that it is semi-liquid. Um, and the way that I would want you to think of the asthenosphere is it's sort of made of a soft rock. It's rock that's a bit more pliable. Remember, astheno means weak. So the asthenosphere is made of soft, weak rock that can flow, albeit very, very slowly. Now, I want you to notice that the asthenosphere isn't completely within the mantle. So this is all made of heavy rock, but that rock is soft and weak. Oftentimes, you're going to see or read that the asthenosphere is plastic. When you see this does not mean plastic as in the things around us that are, disposable. Really, they just mean any substance that is soft and it's going to bend and be able to flow without breaking. So our lithosphere is brittle, it's rigid, and it's going to break rather easily and fracture. Whereas our asthenosphere is more toffee-like or more taffy-like. It's going to bend and be able to flow very slowly without breaking. And so those two properties, along with the sort of their state of matter, really has a big deal on tectonic plates. So what is a tectonic plate? It seems to me that students come into this lesson with a lot of really wrong ideas. The first thing I would want to point out is that the asthenosphere, the lithosphere is not a solid outer shell. It is broken in to these huge pieces. So we can see like a huge piece here, right, that has a continent on it. We can see another huge piece over here that has another continent on it. And so these are actually a good representation of what a tectonic plate is. A tectonic plate is really just huge pieces of the lithosphere. Now remember, the lithosphere is made of all the crust in the solid upper part of the mantle. Sometimes students like to think of these tectonic plates as being underground and then they crash into each other and cause earthquakes. No. Uh, Tectonic plates, when you're outside, you actually are standing on the surface of the crust, and we know the crust is just the part of the lithosphere. So a tectonic plate is what you're standing on the surface of when you are outside. Tectonic plates are not hidden deep underground. Okay, so we can see the top surface of tectonic plates. The top surface of this tectonic plate, part of it's underneath the ocean, and it makes up the seafloor, and it may also makes up the continent of Africa. So all the land of Africa is also part of the top surface of this tectonic plate. Now, one thing that can be a little misleading about this particular diagram, I like it because it shows us that there are separate pieces of the lithosphere, but it might give some of you the idea that there are these gaps in between tectonic plates. There are no gaps. These pieces fit very tightly together, much like a jigsaw puzzle. Okay, so there are separate pieces, but there are not gaps between them. Any place where we have um, two tectonic plates coming together, right? We're going to call that a plate boundary. And so any place where like these plates may grind against each other or meet up against one another, these are something that we just call a plate boundary, sometimes called a tectonic plate boundary. If you look at this map, this really simple map, you're going to find that most of these tectonic plate boundaries are actually underwater, right? They're on the sea floor. I don't really see one here, at least in this image, that cuts through the center of a continent. Okay, so a tectonic plate is a huge chunk of the lithosphere. The lithosphere is not a solid outer shell. It is broken into these huge pieces. So let's take a quick 2D look at a map of some tectonic plates. And I want you to understand that if we look at the entire surface of the Earth, there are about 12 major tectonic plates. And a lot of these tectonic plates are named after the continents that rest up on top of them. Now, this is one of the reasons that we have been studying the continent names. So here we have the North American plate. The Pacific Ocean rests up on top of this, so there's not an actual continent on here, but we call this the Pacific plate. Here's the Australian plate. Um, Europe and Asia together are sometimes called Eurasia. So here's the Eurasian plate. Here's the African plate. Here we have the Arabian plate. This is Saudi Arabia. This is the country of India. This is the Indian plate. And over here we have the Australian plate. So you can see that a lot of these tectonic plates are named after the continent that is part of them. But remember, not all tectonic plates have a continent on them. Like the Pacific plate is one of the biggest chunks of the lithosphere, and it is composed. Its surface is composed entirely of the sea floor, right? So there's no continent on there at all. So one of the things that I really need you to make sure that you're starting to wrap your head around is these tectonic plates, even though there's no gap between them, they're still able to grind against each other and they move. And I want you to think of, so this picture is really kind of handy in the fact that it shows a piece of the lithosphere, a tectonic plate that has been sort of lifted up out of place. And we can see that this is the South American plate. This shows us the continent of South America is part of this tectonic plate. But then we also have, this is the Atlantic Ocean over here. We also have part of the seafloor of the Atlantic Ocean that is also part of the South American plate. And so these huge pieces of the lithosphere, I want you to think of them as sort of floating on top of this semi-liquid asthenosphere. So down here's our asthenosphere, and remember, a tectonic plate is just a huge chunk of the lithosphere. Now, when we talked about continental drift, we said that Alfred Wegener knew that the continents were moving, but he didn't know why. He could never really explain why the continents were moving, even though he had all this evidence that they had moved from their past location. Well, the problem for him is he never understood that there were things called tectonic plates and that the continents weren't moving by themselves. He had kind of imagined that the continents were somehow plowing across the seafloor, but there was no evidence for that. He didn't realize that the continents were simply the tall parts of a much bigger structure, called the lithosphere, which we now call a tectonic plate. So when the continents move, continents are moving really because the tectonic plate is moving, because they're part of something bigger. You may be curious. Okay, so what in the world would be able to move these huge chunks of lithosphere, these tectonic plates? Well, guys, it's pretty simple. It's something that we've already studied. We have much like we might have in a pot of boiling water. Remember, we've said the asthenosphere is a semi-solid, also semi-liquid. And we know that Earth's core is very hot, almost the same temperature as the surface of the sun. So what we have is we have convection currents. Remember, two or more convection currents side by side, that's a convection cell. So we have these convection currents of rock that are essentially dragging in the asthenosphere, that are essentially dragging these pieces of the lithosphere sideways, right? So if this rock is turning very slowly, only inches per year, right? So very, very slowly. But if this rock is moving in a circle like this, if whatever is resting on top of it is going to be dragged in this direction, right? If we have the rock in the asthenosphere right here is turning in this direction very slowly, then the rock that's on top of it is going to be dragged in this direction. So, why do tectonic plates move? Largely because of convection currents within the asthenosphere, and that is simply convection happening away from Earth's core. One way that it's handy for you to think about this is to think about putting the items that you purchase at a grocery store on that conveyor belt. And so, really, the belt itself is kind of moving. The things on the surface of the belt are kind of moving, but really not, right? The mechanism that actually moves the things on that grocery store conveyor belt is underneath, right? It's sort of like a treadmill in that respect too. All right, guys, tectonic plates are huge chunks of the lithosphere. There's about a dozen of them worldwide. Some of them have continents, others don't. They move around, and quite frankly, they move mostly because they're dragged along by these huge convection currents in the asthenosphere. That's going to do it for today. I hope you have a great day. We'll talk more soon.